Okay, um, so what we're going to be doing over the next few days is a lab. This is called the Precipitate lab. Um, I'll teach you more about what a precipitate is once we start actually looking at the reactions. For now, what your instructions are going to be to predict the products of each reaction and then balance each reaction. So this should be stuff that you already have learned, but we're going to go over it for the first few trials in case you haven't learned that yet. This is the Polyatomic Ion List. I put this at the top of your assignment. You're going to need this list throughout the assignment, and I'll kind of show you when you need to use it. Okay, so our first reaction is barium chloride reacting with sodium sulfate. All of these precipitate reactions are double replacement reactions. So what does that mean? That means that the nonmetals are going to trade places. So the chloride's going to trade places with the sulfate, excuse me. So when they trade places, now barium is with sulfate and sodium is with chloride. Okay, so the next thing we need to do is make sure that the charges are balanced with these ions. Example, barium has a +2 charge. We can tell that from the periodic table, right? It's in the second row. All these elements in the second row form a +2 charge. Barium's no exception. Barium also has 2 valence electrons, so that's another way you can tell it has a +2 charge, is it wants to lose those 2 valence electrons so that it has an empty valence orbital. Okay, and then sulfate is a polyatomic ion, and sulfate has a charge of -2. So for all the polyatomics, you're just going to look on the chart. Sulfate's -2. Okay, and then for sodium chloride, again, we're going to look at the periodic table. Sodium's right here. It's in column 1. It has 1 valence electron. It's going to lose that 1 valence electron to have the same electron configuration as neon. And when it loses that valence electron to have an empty valence orbital, it will form a +1 charge. So sodium is +1. Chlorine, on the other hand, has 7 valence electrons. It wants to have 8 so that it has a full valence orbital. So it's going to gain 1 electron, and then it'll have the same electron configuration as argon. So it'll go from 7 to 8. So we'll see, since it's gaining an electron, it'll have a -1 charge. +1 and -1 cancel out, so this one is also already balanced. Okay, so then all we have to do then is balance the number of atoms using the coefficients. So right now on the left side, I count 1 barium, 2 chlorine, 2 sodium, and 1 sulfate. 1 barium, 2 chlorine, 2 sodium, 1 sulfate. And on the right side, on the product side, I count 1 of each. 1 barium, 1 sulfate, 1 sodium, 1 chlorine. Okay, so we need to balance the sodiums and the chlorines because we have 2 on this side and 1 of each on this side. So we'll do that by putting a 2 in front of NaCl. And that will change the number of sodium atoms and the number of chlorine atoms to 2. Okay, don't worry about answering this question or doing either of these two things, right? Labeling the soluble and insoluble products. We haven't learned that yet. That's going to be, I'm going to give instructions on how to do that at the end of this lesson. So for right now, just focus on predicting the products and balancing the reaction. If you want to watch the actual reaction, you can. That's using the link at the top here. Eventually, you will have to watch all the reactions to determine if a precipitate formed but we're not doing that yet. So, whoops. So for the time being, just don't worry about that part. Okay, next reaction. We've got potassium iodide reacting with sodium chloride. Again, this is a double replacement, so the iodide and the chlorine are going to trade places. So that's going to give us potassium chloride and sodium iodide. Next, we want to check the charges to make sure that these chemical formulas are balanced. So we'll start with potassium. Potassium's in group 1. Remember, all these ones in group 1 form +1 ions. That's because they have one valence electron. So potassium is no different. It will form a +1 ion. Chlorine, on the other hand, because it has 7 valence electrons, it's going to gain an electron and form a -1 ion. So this one's already balanced. We don't have to add any subscripts to balance that one. Let's take a look here. Sodium has a +1 charge. Again, that's because it has 1 valence electron. And iodine will form a -1 charge. It's because it's going to gain 1 electron, so that it has 8 valence electrons instead of 7. So it'll have a full valence orbital. Okay, so both of these are already balanced. We don't have to add any coefficients. So these first two trials were pretty easy ones to balance the chemical formulas. We didn't need to add subscripts at all. So now let's count up the atoms. Looks like we have 1 potassium, 1 iodine, 1 sodium, 1 chlorine. And really same thing on the product side. 1 potassium, 1 iodine, 1 sodium, 1 chlorine. So this one's already balanced. We don't really need to do anything with this one. We can just get rid of the spaces for the coefficients. And then, again, you don't have to worry about the bottom 3 instructions or watching the video yet. Eventually, we will do this, though. So you can skip out on those for right now. Okay, let's do one more example together. This one's a little bit tougher. We have lead nitrate and sodium hydroxide. Again, it's a double replacement, so the nonmetal is going to trade places with the other nonmetal. In this case, they're both polyatomic ions. So we're going to pair up lead with the hydroxide, OH, and we're going to pair up sodium with the nitrate, NaNO3. Okay, so first we're going to worry about charge. First element we need to worry about is lead. Lead you can't really figure out from just looking at the periodic table, and that's because lead has more than one oxidation state, because it's a post-transition metal. So that means it can have different charges. It can be +2, it can be +4. There might be one other lead ion, I'm not sure. It can for sure be +2 or +4 though. So for this one, I'm just telling you that lead forms a +2 ion. So you can go ahead and write +2 down here. Hydroxide, we're going to get that from looking at the polyatomic ion list. So here's hydroxide. It's got a minus sign. That means -1. And so this one's unbalanced, right? Remember that ionic compounds have a net charge of 0. So we need to balance that out by doubling the amount of hydroxide ions. So we're going to put hydroxide in parentheses, and then we'll give it a little subscript 2. Okay, so it wasn't showing up right when I was doing it in full screen, so I'm just going to do it in edit mode for the rest here. So again, we needed to add this subscript 2 to balance out the charges. We need 2 hydroxide ions to balance out the positive charge of the lead ion. Okay, so then next up, let's do sodium nitrate. Sodium has a +1 charge. Again, that's because when we look at the periodic table, sodium has 1 valence electron. Nitrate, on the other hand, that's a polyatomic. Nitrate is NO3, and it has a negative charge, which means -1. So we've got a +1 and a -1. So this one's already balanced, so we don't need to add any subscripts to balance this one out. Okay, and then lastly, we're just going to balance the reaction. So we've got lead, nitrate, sodium, and hydroxide are products and reactants. There should be one lead atom, 2 nitrates, 1 sodium, and 1 hydroxide on the reactant side. On the product side, there should also be 1 lead and 1 hydroxide, but there's going to be, 1 lead and 1 sodium, but there's only going to be 1 nitrate and there's going to be 2 hydroxides. And that's because of this little subscript 2 here, 2 hydroxides, but only 1 nitrate. Okay, and so then let's continue with our atom accounting. We want to count, we want to adjust the number of nitrate atoms, because we have 2 over here and only 1 over here. So we'll do that by putting a 2 in front of NaNO3. And that's going to change the number of sodium atoms to 2, and also the number of nitrate atoms, so 2 and 2. Okay, and so then now our number of sodiums and our number of hydroxides don't match because we have 1 here and 1 here. So we're going to fix that by adding a 2 right here. And so then we should see that the number of reactants and products are all the same now. And so then that's going to be our chemical formula. And so don't forget that you don't have to do the bottom 3 or the top 1 yet. Eventually we are going to answer these, but for the time being, that should be all that you need. So go through and predict the products and balance the reaction for trials 4 through 15. If you have any questions, contact me.